So this video is on adding or subtracting radical expressions. Key thing to note, and oftentimes where people go wrong, is doing what you see up here. Square root of a plus b to be equal to square root of a plus square root of b. That is absolutely wrong. You cannot split a radical if you have a plus sign or a minus sign between two expressions. But on the other hand, if we have square root of a times b, or any root nth root of a times b, we can split it up and write it as the nth root of a multiplied by the nth root of b. In a similar manner, the nth root of a over b, we could write it as the nth root of a divided by the nth root of b. But we cannot do it if we are doing the nth root of a plus b or the nth root of a over b. So I'm just going to put n here to demonstrate that this holds true for any root, nth root, second root, or third root, and so forth. So we want to combine terms here. If you look at the first problem, we have root 3 in common. So if I pull root 3 out from the first term, I'll have 1. If I have root 3 out from the second term, I have 7. So 7 plus 1 is 8. The answer is 8 times root 3. The same in the next problem. So we have root 2, root 2. We have root 2 in common. If root 2 comes out of the first term, we have 10 left. If root 2 comes out of the second term, we have negative 4, and 10 minus 4 is 6, so 6 times root 2 would be the answer. In the next problem, though, we have nothing in common between root 5 and root 3. So the only thing that we can do here is we use a calculator to find the answer. So this is numerically found . Part D is a bit tricky. A reason being, we could write the first one as square root of 2. The second one is the third root of 2, which is 2 raised 1 over 2, plus 4 times 2 raised 1 over 3. Now you could see that there is nothing in common between 2 raised 1 over 2 and 2 raised 1 over 3. But could we rewrite somehow in terms of 2 raised 1 over 2 so that we can pull a term out? We certainly can. We could write 4 as 2 times 2. And we could write 2 as 2 raised 1 over 2 times 2 raised 1 over 2, because the bases are identical. So I can add the powers. So the first 2, I'm writing it as 2 raised 1 half, 2 raised 1 half. The second 2, I'm just going to leave it as is. And the third one would be 2 raised 1 over 3. Now I have a common 2 raised 1 half between the two terms. So I could pull that out. If 2 raised 1 half comes out of the first term, I have 1. I'm pulling out 1 2 raised 1 half, so leaving me with 1 2 raised 1 half inside, times 2 raised 1 times 2 raised 1 over 3, which would mean square root of 2 times 1 plus. Here, the bases are identical, so I can simply combine the powers. So 2 raised 1 half plus 1 plus 1/3. So we would get square root of 2, 1 plus. To combine the powers over here, we need to find a common denominator, which in this case would be 6. So 3 over 6 and multiplying and dividing by 3. 6 over 6 multiplying and dividing by 6. 2 over 6 multiplying and dividing by 6. So we have 1 plus 2. We have a common denominator of 6. We add the numerators. We have 11 over 6. Which would simply give us root 2 plus the 6th root of 2 raised 11. So here is an interesting radical expression which at the outset might look as if you can't combine it or simplify it, but we actually can. So we could write 27 in terms of a perfect square, which is 9, so 9 times 3. We could write 75 as 25 times 3. We can split the root as square root of 9 times square root of 3 plus square root of 25 times square root of 3. This would become 3 root 3 plus 5 root 3, which would give us 8 root 3. Technically speaking, it is plus or minus because we have a square root, so we could put it as plus or minus 8 square root of 3. But in a problem like this, there is nothing wrong if we leave it as 8 times root 3. This problem is similar to the previous one. Just by looking at it, it might seem as though we can't combine them and simplify, but if we could rewrite it in terms of a perfect square, we could rewrite 20 as 4 times 5, and we could rewrite 45 as 9 times 5. We can split the roots and write it as square root of 4 times square root of 5 minus 7 times square root of 9 times square root of 5. We know that square root of 4 is 2 and square root of 9 is 3. I'm ignoring the plus or minus part to keep the problem simple. So I have 6 root 5 minus 21 root 5, which would give us negative 15 root 5. This is similar to the previous problem. By the looks of it, it seems as though that we can't combine it, but what we can do is we can try and write it in terms of a perfect square. So we could write 75 as 25 times 3, 12 as 4 times 3, minus 3 root 3. I could split the roots and write it as square root of 25 times square root of 3, square root of 4 times square root of 3, minus 3 root 3. Square root of 25 is 5, so negative 5 root 3, plus 2 root 3, minus 3 root 3. Negative 5 root 3, plus 2 root 3 is negative 3 root 3. So negative 3 root 3 minus 3 root 3 is negative 6 root 3. So now we move on to expressions rather than simply numbers. So first, we want to write it in terms of perfect squares. I could write 45 as 9 times 5 times x squared times x. Y, x squared, is a perfect square, plus x times 5 times root x. There is nothing I could do about root x, so I'm going to leave it as is. And now we are going to split the root, write it as square root of 9 times square root of 5 times square root of x squared times square root of x plus x times 5 times square root of x. Square root of 9 is 3. Square root of 5, we could do nothing about it. Square root of x squared is simply x, and we have square root of x plus 5 square root of x. So we have 9 times square root of 5 times x times root x plus 5x times root x. If I rearrange the terms, I would simply have 9x plus or times root 5 times root x plus 5x times root x. We can see that square root of x is common in both terms. X is in common between both terms. So if we pull those out, we're pulling x root x out, which would leave us with 9 root 5 in the first term and 5 in the second term. Here we have a radical expression involving sums and differences, but we have cube roots instead. So the objective here is to write whatever number that is inside the root in terms of a perfect cube, because we have a third root. So I could rewrite 64 as 4 cubed. I cannot write 14 in terms of a perfect cubed, because the factors of 14 are 7 and 2. So we're just going to leave it as is, and minus 9. Those two the root and the power would cancel each other out, and we'd have 4 plus cube root of 14 minus 9, which would equal to the cube root of 14. 4 minus 9 is negative 5. So here we have two fractions, and they both have radicals in them. So anytime we want to combine fractions, we need to have a common denominator. The common denominator here is 12. So we multiply and divide the first fraction by 3, and multiply and divide the second fraction by 4, which gives us 3 square root of 45 over 12 minus 4 square root of 5 divided by 12. We have common denominators, so we can combine them and add the numerators. And now that we have radicals in the numerator, we are going to try to write them in terms of perfect squares so we can pull common terms out. So I could rewrite 45 as 9 times 5. Now I could split the root as 3 times square root of 9 times square root of 5 minus 4 square root of 5 divided by 12. We know square root of 9 is 3, so we have 3 times square root of 5 minus 4 square root of 5 divided by 12, which would be 9 square root of 5 minus 4 square root of 5 divided by 12. 9 square root of 5 minus 4 square root of 5 is simply 5 square root of 5 over 12. The next objective here is to multiply radical expressions. Multiplication is pretty much straightforward. The first step would be to write it in terms of exponents. So we have 3 raised 1/2 times 3 raised 1/2 minus 2 raised 1/2. When we distribute the 3 raised 1/2, we have 3 raised 1/2 times 3 raised 1/2 minus 3 raised 1/2 times 2 raised 1/2. The bases are identical in the first term, so we combine the powers. In the second case, though, the bases are not identical, so we can write it as 3 times 2 raised the common power, which is 1/2. So if I add those two 1/2s, I get 1. 3 times 2 is 6. So the answer is 3 minus square root of 6. With practice, you would be able to do this faster. Another way to look at it, this problem, we could write it as square root of 3 times square root of 3 is square root of 3 squared, minus square root of 3 times square root of 3. Now, square root of 3 squared, the root and the power would get cancelled, so you would simply have 3. And root 3 minus root 2 is square root of 3 times 2. You have 3 minus square root of 6. Obviously, this approach right here is simpler compared to that approach right there. So using the easier approach, what we can do now in the second problem is to FOIL. So root 3 times root 3 plus 8 times root 3 minus 8 times root 3 minus 8 times 8. Root 3 times root 3 is root 3 squared. Those two terms are identical and of opposing signs, so we get 0. Negative 8 times 8 is negative 64. The power and the root will get cancelled, so we have 3 minus 64, which is negative 61. Here we have a radical expression raised to the power of 2. We're going to start by rewriting this expression as square root of x plus 1 plus 2 times square root of x plus 1 plus 2. So that is the first term, that is the second term, so we can FOIL square root of x plus 1 times square root of x plus 1 plus 2 times square root of x plus 1 plus 2 times square root of x plus 1 plus 2 times 2. Square root of x plus 1 times square root of x plus 1 is square root of x plus 1 squared. 2 square root of x plus 1 plus 2 square root of x plus 1 is 4 square root of x plus 1, and 2 times 2 is 4. The root and the power here will get cancelled, and we will have x plus 1 plus 4 square root of x plus 1 plus 4. We can combine the 4 and 1. 4 plus 1 is 5, so we have x plus 4 square root of x plus 1 plus 5.